Swayam Prabha. Digital India. Educated India.
Now I found the displacement field. Next what I want to do is I want to find the gradient of the displacement field. Okay. Next I want to find H, which is gradient of the displacement field U, similar to what we have been doing all along. So this will be dou Ux by dou X, dou X by dou Y, dou X by dou Z, uy by dou X, dou uy by dou Y, dou uy by dou Z, dou uz by dou X, dou uz by dou Y, dou uz by dou Z. If I substitute the components of displacement from here into these components, I will get 0 minus omega Z minus omega Y, omega Z, 0, omega X, 0, 0, 0. Right? Okay. Now I want to compute the linearized strain epsilon, that is 1 half H plus H transpose. So that will be given by the epsilon x y term will get cancelled because it's q symmetric in xy component. So I will get it as 0, 0 minus omega y, 0, 0 omega x minus omega y omega x 0 into half. Okay. Now next I have to, from our scheme of things here, I found a displacement field suitable for the boundary problem that I am studying. I use a strain displacement relationship to get the strain. Next I have to use the constitutive relation to get the stress, and then I have to check whether the equilibrium equations are satisfied or not. Okay, so that's the scheme of things now. So my stress expression is given by lambda trace epsilon identity plus 2 mu epsilon, and I find here from here that trace of epsilon is 0, and hence this becomes mu times 0, 0 minus omega y, 0, 0 omega x minus omega y omega x 0. Okay. Now I found the stress. I found in particular sigma xz component to be minus mu omega y and sigma yz component to be mu omega x. Okay. Now I will see what happens to the equilibrium equations next. Okay. The equilibrium equations are, I am assuming there are no body forces and the body is in static equilibrium. So the equilibrium equations will reduce to recurring divergence of sigma equal to 0, which is dou sigma xx by dou x plus dou sigma xy by dou y plus dou sigma xz by dou z, dou sigma xy by dou x plus dou sigma yy by dou y plus dou sigma yz by dou z, dou sigma xz by dou x plus dou sigma yz by dou y plus dou sigma zz by dou z. This you can see that sigma xz is not a function of z or x, and hence the first equation is identically 0. The other two components are 0. The second equation sigma xy is 0, sigma yy is 0, sigma yz is not again a function of z, so that is 0. The third equation sigma xz is not a function of x, sigma yz is not a function of y, and sigma zz is 0, so that is also 0. So your recommended divergence of sigma be 0 is satisfied by this stress field. Okay. Now the unknown is your angle of twist per unit length omega, which you will find from the requirement that the torque is given by sigma yz into x minus sigma xz into y d a z a z. Okay, I substitute for the expression for the stresses into this equation to get the torque to be equal to omega times mu x square plus y square daz az. Okay, now I use this expression to find the related torque to the angle of twist omega. Okay, now further simplification is possible if I assume that the member is or the structure is homogeneous, assuming homogeneous body, I have T to be given by mu omega. I can pull the mu outside since I assume the body is homogeneous. The shear modulus mu is not a function of x, y or z, so I move that outside. That will be x square plus y square dax dx dy az. Okay, this is the definition of polar moment of inertia J, which is the polar moment of inertia. Okay, that is x square plus y square is r square, so I can write it as mu omega mu r square dA az. Okay, and this r square dA is the polar moment of inertia. Okay, J. Okay, so I have now the expression T by J equal to mu omega. Okay, mu omega. Now I have to find what is the effective shear stress in the cross section, right? Now I know that from the expression for the shear stresses in here, I know that sigma xz is minus T by J into y, and sigma yz is T by J into x, and sigma yz is T by J into x. Okay, now what I am interested, I am not interested in the components of the shear stress, but I am interested in the magnitude of the shear stress, right? So the magnitude of the shear stress tau is given by square root of sigma xz square plus sigma yz square, because these are acting in the same plane. Okay, so this will be T by J root of y square plus x square. Y square plus x square is the radial distance of the point. Okay, so this is nothing but T by J into r, where r is the radial distance of the point in the cross section from the center of rotation. Which is usually the CG or the cross section. Okay, so combining these equations, I have tau by r equal to T by J equal to mu omega. Okay, so this is called as the torsion equation. This is called as the torsion equation. Okay,